how do we multiply numbers in scientific notation? So as a general rule, we have to multiply the coefficients together, and we need to add the exponents together. So that's the thing you have to remember, but let's work through some examples and prove to ourselves that that's true. Let's start with a nice simple example first. How about 10 to the power 3 times 10 to the power 2? So let's write this out in longhand. So that's 10 times 10 times 10. That's this guy. Times 10 times 10 for this fella, which is equal to 100,000 if you multiply those all together. And now let's go backwards from decimal into scientific notation by moving the decimal place, as we just learnt how to do. So if we want the decimal place here, we've got to go 1, 2, 3, 4, 5 places to the right. So that's 10 to the power 5. And it's no coincidence that 5 is equal to 3 plus 2. And that should be true in all cases, that if you add the exponents together of these two numbers, then that should be right. And of course these numbers, this should actually be 1 times 10 to the 5. Because multiplying a number by 1 doesn't change it, as we well know. So now how about if we have numbers with slightly more complicated coefficients to them? So for example, how about 3 times 10 to the power 3 times 2 times 10 to the power 4? So again, let's write this all out in longhand. So we've got 3 times 10 times 10 times 10 times 2 times 10 times 10 times 10 times 10. 1, 2, 3, 4 tens. Okay, and then because we can multiply numbers in any order we feel like, let's rearrange the 3 and the 2 to be together here at the beginning. And then all the 10s together. So 10 times 10 times 10 times 10 times 10. 1, 2, 3, 1, 2. Okay, so we've got all the 10s together. So then multiply 3 times 2, that gives us 6. And then here, if we multiply all these together, that gives us 10 million. And then again, we can move backwards from this 10 million back into scientific notation. So that's to move the decimal place, from here back to here. That's 1, 2, 3, 4, 5, 6, 7 places. So that's 6 times 10 to the power 7. And again, it's no coincidence that 7 is equal to 3 plus 4. So we could have just added the two exponents together and got the same result. So if we want to write out this general rule as a nice fancy equation, we could say that if we've got two numbers, so c times 10 to the power a times b times 10 to the power d, that's equal to c times b times 10 to the power a plus d. So all this a, b, c, d, that could just be equal to any number you feel like. Alright, so if we, now let's take an example that's using negative exponents and show that it's just the same. So how about if we took 3 times 10 to the power minus 3 times 2 times 10 to the minus 4. We'll just work through it in the same way. So that's 3 times 1/10 times 1/10 times 1/10 times 2 times 1/10 4 times. There we go. And then we can rearrange them. So that's 3 times 2, let's put that at the beginning, times 1 over 10 million. So that gives us 6 times 1 over 10 to the power 7. So that's 6 times 10 to the power minus 7. And if we just added the two exponents together, that would give us 6 times 10 minus 3 plus minus 4, which is the same as minus 3 minus 4, which is minus 7. So that's 6 times 10 to the power minus 7 by this method as well.